Hi students, we're going to start with exercise 7.4, the first sum. It is given to us that AB is equal to AC, angle ABC is equal to angle ACB is 45 degrees, that is the base angles are 45, and therefore by the sum of the all angles of the triangle is 180, angle A, which is theta, is 90 degrees, which was not directly given to us but indirectly given, but we could find out the value of theta. Now if you know that theta is 90 degrees, radius is 7 root 2, we have to find out the area of the segment BXC. Now area of the segment BXC, we know the formula, it is r square pi theta upon 360 minus sine theta upon 2. Now using this formula, putting the value of the radius as 7 root 2 the whole square, putting the value of pi as 3.14, theta as 90 degrees upon 360 minus sine 90 divided by 2. Now 7 root 2 the whole square is 49 2s are 98 multiplied by. Now here you can see a 0 getting cancelled. 9 1s are 9 4s are 2 2s are, and 2 always goes by 1.57. So it is 1.57 upon 2. Sine 90 I told you in the earlier video is 1. So 1 upon 2. I'm just writing it here. Sine 90 is 1. Thus calculating 98 into, this is 1.57 minus 1 upon 2, which is 98 into 0.57 divided by 2. Okay, now we need to calculate this. This is 49 into 0.57, and when you calculate 0.49 into 0.57, it comes to 27.93 square centimeters. This is the area of the segment. Now when I go to the second sum, it is given to you as, we have a circle, the value of theta यहाँ पे it's given to you as 60 degrees, and you have the radius as 10. So we are supposed to find out the area of the segment PQR in the figure. Now directly they did not give you 60 again, they give you the measure of the arc PQR, which is 60. Hence the value of theta is 60 degrees, the radius is 10, and again we have to find the area of the segment P dash Q PQR, you can just say that way. Okay, is how much? Now we know the formula, area of the segment is equal to, yes, come on, r square pi theta upon 360 minus sine theta upon 2. Now the radius is 10, so 10 square. Pi value is always 3.14. Theta is 60 degrees upon 360 minus sine 60 upon 2. Now this is 100 into, again a calculation here, the 0 gets cancelled. 6 1s are 6 6s are, 2 always goes here with 1.57. So it is 1.57 upon 3 minus sine 60, I had told you it is root 3 upon 2, and r2 which is already down there. So I'm again writing here sine 60 is root 3 upon 2. So calculating the value inside the bracket, it is 1.57 upon 3. The value of root 3, they will give you 1.73. 1.73 divided by 4, which comes to, yeah, so we're just going to cross multiply here. This is 100 into, this will be 1.57 into 4, which is 6.28, minus 1.73 into 3, which is going to come to 5.19 divided by 12. Continuing further, which is equal to 100 into, when I subtract it, I get 1.09 divided by 12. Doing calculation further, this is 109 divided by 12, and that comes to 9.08 centimeters square. So this is the area of the segment. Everywhere you have to be particular about doing the calculations properly. In the third sum, they have given us, there is a center A. The area of the segment we have to find out here, where the value of theta is 30 degrees and the radius given to you is 7.5. The segment is PQR. I need to draw the segment and shade it off. So again, the value of theta is 30 degrees. The radius is 7.5, and you have to find the area of the segment is how much. Again, using the same formula, area of the segment is r square pi theta upon 360 minus sine theta upon 2. Here, we'll substitute the value of the radius as 7.5 the whole square into 7.5 the whole square into bracket 3.14 into theta, which is 30 degrees, upon 360 minus sine 30 divided by 2. This comes to 56.25, 7.5 the whole square. Again 0, 0 gets cancelled, 3 1s are, 3 12s are, 2 6s are, to 1.57. So it's 1.57 upon 6 minus sine 30 is half. So R2, that comes to, I'll again write here, sine 30 is half. Calculating 56.25 into 1.57 upon 6 minus 1 upon 4. Again LCM we need to take 56.25, and if I consider LCM, you can even cross multiply. I'm going to consider the LCM as 12. So 6 multiplied by 2 makes it 12. So 3.14, and 4 multiplied by 3, which makes it 12. So again I multiply 1 with 3, which is 3. So it is 56.25 into bracket 0.14 divided by 12. Calculating all this, we will get the answer as 0.66 square. Right now no centimeters is given, so you can write it as square units. I'll continue with the fourth sum now. In the fourth sum, they have given me the value of theta is 90 degrees. Like you can see here, it's 90 degrees. We have to find the area of the segment PRQ. Here, the radius given to us is, no, in this sum they have given us theta is 90 degrees, area of the segment is 114, and we have to find the radius. So this is again a different sum, but the same way you have to carry on. So we know area of the segment is equal to r square pi theta upon 360 minus sine theta upon 2. Now this time they have given you the area of the segment, which is 114. I don't know the value of the radius. I know the value of pi, which is 3.14, theta, which is 90 degrees, upon 360 minus sine 90 upon 2. And as you all know, sine 90 is 1. So 114 is equal to r square. Cancelling it out here, 0, 0 cancel, 9 1s are, 9 4s are, 2, and this is 1.57 as usual. So 1.57 upon 2 minus sine 90 is 1, so 1 upon 2. 114 is r square. This will be 1.57 minus 1 upon 2 because the denominator is the same. So 114 is r square. This is 0.57 divided by 2, which is nothing but, we'll cross multiply, 114 into 2 divided by 0.57 is r square. You calculate this further, you will get the value of r. After cancelling 57, you get the value of r as r square. R is 20 degrees. R square comes to 400. R square is 400, so r is 20 by taking square root. Now we move on to the fifth sum, in which they have given us a chord PQ of a circle with radius 15, subtends an angle of 60 with the center of the circle. Find the area of the minor as well as the major segment. Now here I'm just going to draw the figure and give it to you, and I want you to do the sum. Here the measure of the central angle is 60 degrees. The radius of the circle is 15 centimeters. Right? So your theta is 60 degrees. The radius is 15 centimeters. You have to find the area of the minor segment. In short, it is this segment only. So you're going to use the same formula. I'll just write down the value of sine theta for you, which is sine 60, which is root 3 upon 2. So here you can write just 60. So you're going to do this. Now after you find the area of the segment, you'll find the area of the circle by using the formula pi r square. Then area of the major segment will be equal to area of the circle minus the area of the minor segment, and you'll get the answer. I'll just send the answer across. The answer for the area of the minor segment, those are working on it, is 20.44. Area of the circle is 706.5, and the area of the major segment will come to 686.06 centimeter square. Everywhere you have centimeter square. Thank you.